It's a tough life in the great outdoors. Finding food and battling the elements. Dangers lurk at every turn. Every day could be your last. Is there any way out? There is. If you can find a way in. No matter how tidy it might be, your home teems with life. Just how much will be revealed by a team of biologists who are setting up camp in this family's house to uncover the secret world that lies within it.
Hey, Matt, you gotta see this.
Oh, cool.
From the familiar to the alien, it's a new frontier, an uncharted zone.
What is that?
The stable, orderly nature of our neighborhoods is an illusion. Because as much as we like to pretend that they are oases of tranquility, our homes hold within them a fierce and wild world. Here, the great struggle to survive goes on all around us. The cold calculation of the hunter, the anxiety of the hunted, all within the quiet confines of your walls. Welcome to the great indoors. Every corner, a potential lair. Every carpet, a dense forest. In the wide spaces of your kitchen, an open savanna where the food is abundant, but so is the danger. We humans are an indoor species, spending nearly 90% of our lives under a roof. And yet we know next to nothing about all the life that lives with us. Arthropods, insects and their relatives, the most successful creatures on Earth. They've outlived the dinosaurs.
Emerson, breakfast time.
They've witnessed the rise of mammals, and they've watched our species spread across the globe. And now they watch us go about our day. So who's really living with whom?
Some bugs are good, like spiders, right?
I think one of my friends said that they're good for eating mosquitoes.
Do they? I have no idea.
I don't know.
To unveil this secret world hidden in plain sight, a team of entomologists will set up camp in the Toronto home of the Vatisse family.
So what kind of bugs do you think they're gonna find inside?
Butterfly,
Yeah?
flies.
Bees?
Yeah.
Not everyone would want to know about all the creepy crawlies in their house. But this family will get a full report.
What if they find bugs in your room?
Meet the intrepid explorers of the great indoors. Michelle Troutwine, expedition leader, and her partners, Misha Leong and Matt Breton. It's their first time in Canada.
Ooh, that's a good bee garden.
Together, they've scoured homes on 4 continents, exploring the wildlands of what they call the indoor biome.
It's this incredible new frontier, and it's so unexplored, even though it's such a common and familiar place. So I'm really excited about making big discoveries close to home.
Nice to finally meet you.
Come on in.
Let me tell you a little bit about the project. Okay. We want to explore the diversity of arthropods in your house. And so, believe it or not, scientists know a lot about a handful of pest species that we live with, like, for example, roaches and ants and termites. But we don't know a lot about the many, many other species that live in our house. And so we really get to be indoor explorers, discovering all the bugs in your house.
Have you been noticing any insects or other arthropods? Anything?
Yes, we've been noticing what we think are flower mites in the pantry.
Huh.
We'd like to know more about those.
Okay.
Some pantry pests, okay.
Well, let's see if we can
We'll
find
look
some.
into it.
Yeah, yeah.
Great. Well, now we're going to kick you guys out.
All right.
Yeah. We'll have fun.
In order to establish a baseline for where they are, Misha has a look around, outside the house.
A lot of times what you find inside a house is a reflection of what's going on outside as well. And so for every house that we look at, we like to get an idea of what the exterior on the property looks like. So we take measurements on what the low vegetation shrubbery and grasses are and what the tree diversity is as well and how much there is of each. And then also just get a general feel for what the neighborhood looks like.
The house is located in central Toronto. It's 8 kilometers from Lake Ontario and a few blocks from a large tree-filled cemetery. It's a typical urban neighborhood. And when you consider that these built environments are the only environments on Earth that are growing, it's high time we learned what creatures call it home. The bug crew brings in some Canadian experts.
Hey, Morgan.
Morgan Jackson of the University of Guelph, and Spider Woman Maidiane Andrade from the University of Toronto. Collecting indoor wildlife is just one part of the work. The team is also setting up a lab because they'll need to identify what they find. What they find will help them unveil the workings of the indoor biome. Where, for example, do all these critters we live with come from?
Do you want to try an insect?
Yeah, let's do that.
That'd be great.
Some wander in from outside, but others live only indoors.
Oh, beautiful.
Take the carpet beetle. It's found in nearly every home. Yes, yours too. Their larvae feed off the wool in your carpet. But what did they eat before we had carpets? What did clothes moths eat before they had our sweaters? How did they all get in here?
You guys ready to sample this house?
Absolutely.
Anyone have any preferences?
Basement?
Kitchen.
I'll go in the basement too, yeah.
Okay, great.
How about you, Morgan?
I can do the mudroom, and then I can help out up here if you want.
Great, maybe the living room?
That sounds great.
All right, well, let's go, guys.
All right.
Awesome.
Yeah.
While nothing is for sure in the wilds of the great indoors, Michelle's team expects to find some of the usual suspects.
All right, good to
Yeah,
go.
you ready?
Let's do it.
Look closely through your home. You'll probably find spiders, beetles, flies, ants, silverfish, centipedes, and perhaps this guy. The pill bug, also known as the woodlouse, roly-poly, or potato bug. But it's not really a bug at all. It's not even an insect. It's a crustacean, more like a crab than an ant. They breathe through gills, which means they need moisture to survive. This female moved indoors to escape a rainstorm. The new terrain is unfamiliar, unlike the soft earth outside. If she's going to survive indoors, she'll need to stay in the damp of the basement. Because the real danger now is drying out. And she'll need to avoid the spiders that love to dine on her kind. And she'll also need to avoid getting scooped by Matt and Maidiane. Maidiane Andrade is an expert on black widows, but really keen on everything with 8 legs.
Oh, I got a lot of cobwebs back here. Oh, and I can see about 100 little moleskins from spiderlings. So there must be some egg sacs in here that have hatched recently.
Basements are rich with life. But finding the creatures of the indoors takes some skill. A trained eye to know what it is you might be seeing.
Oh, hey, Matt.
Yeah.
You gotta see this.
In a mess of webbing, Maidiane appears to have found 2 spiders, right beside one another. But in fact, it's just one.
I've got a funnel web spider, and she's just molted. She's right underneath her old skin.
Like all arthropods, spiders must shed their external skeleton as they grow larger.
So usually after they molt, they just sort of hang out someplace where they'll be protected because their body's kind of soft and they're vulnerable, which I guess is why she tolerated me moving this door. There's all sorts of mummified prey along this web and some others here on the door.
You know, I thought she was a funnel weaver, but she's a lot bigger than I expected.
Yeah, her head is pretty massive. It might be a closely related hacklemesh weaver.
Oh, look at those fangs.
Yeah, I would not want to get bit by her.
Nice, that's a good find.
Very pretty spider.
Many of the insects that live in our homes are tiny, nearly invisible. And those that aren't sometimes make themselves invisible.
Oh, cool. That is something I don't think I've ever seen in real life.
What'd you find, Matt?
It's a little assassin bug called a masked bedbug hunter. These hunt various insects, not just bedbugs. They're really cool because they're all covered in dust to help camouflage themselves. Very, very cool critter.
Dead or alive, all the creatures the team finds can be counted as part of indoor life. In this corner, Mediane finds a familiar creature of the great indoors. Cellar spiders can't survive our winters, so indoors is the only place you'll find them.
So this cellar spider, she's got a really nice, large, tangled kind of a web. And essentially gives her trip lines, gives them a lot of sensitivity for catching prey. And one of the things that these cellar spiders do when a predator comes near is to respond by moving so rapidly that they essentially become a blur. They don't actually run, but what they do is flex and extend their legs so their body starts to oscillate or rotate in the web. And it makes it hard for the predator to figure out where they are and to actually catch them.
The dark and damp of the basement makes it ideal habitat for many critters. And the spiders gathered by Mediane and Matt feed on all of them.
She's really big.
That is massive.
But upstairs in the kitchen, Michelle and Misha are tracking different homebodies.
There's another weevil.
One of the great tools of the indoor explorer is the aspirator, used for sucking up bugs. A tiny filter inside the tube stops them from going in your mouth.
Michelle, I got a ton of weevils in this corner.
I know, I bet they're coming from the pantry there.
All right, let's check it out.
Michelle and Misha confirm that pantry beetles are living large in the Vatisse cupboard. But it's an old story, really. Pests like these have been troubling people ever since humans started storing grain.
We're finding a couple different kinds of little tiny brown beetles. One of them's a weevil, and the other one is another type of pantry pest. Although I think pest is a little bit of a dirty word for them. They're pretty benign, but they love to feed on all the stuff you see in here, so flour and oats. If you ate these in your cereal, it would be no big deal. It would be like sprinkles on top. It would be an extra crunch, that's it.
This particular case may be no big deal, but if left unchecked, these guys can get out of hand.
Oh, wow! This is basically like a little apartment building. There's 2 different species of beetles and some babies, and they're all just kind of living in the, I guess, oat clump.
The specimens are captured and preserved in ethanol. They'll be sorted and identified later.
Hey, Matt, take a look at this.
Back in the basement, one beetle faces capture of a different kind.
This beetle is wandering really close to that female's web. Oh,
It's over
look,
here?
she's chasing it. They're about the same size, so it's kind of
Very interesting.
maybe a
to
battle
see.
royale.
Oh, nice.
In the silk. And she's, see her hind legs there? She's throwing out sticky silk,
Great.
and he's struggling. The web itself actually is not that sticky. And that's the thing about cobweb weavers. It really depends on their skill at wrapping the prey. Oh, she's going in to bite, and then she'll back off for a while and see if that venom has taken effect. And usually they'll sneak back down and sort of touch the animal again, and if it's still struggling, they back off. But we'll see if she's actually successful against this beetle, because it is about the same size as her. I think we should just catch both of them right now.
Morgan is a grad student whose specialty is flies, which is perhaps why he heads straight for the windows first.
So far, we've got a megachilid bee, a solitary bee, and a couple of tiny little beetles. Very little, considering we're right at an entryway.
Where you find a creature is a telling indicator of how it got indoors. This is a stink bug. Originally from Asia, they're common enough here, but are usually found outdoors. Now, in this back room, it likely walked in right under the door. While it searches for a way back out, It needs to deal with the uncommon terrain of the indoors and the threats. Another intruder, a hunter, spots it. But this bug doesn't care. It has a secret weapon. The stink bug stinks. Quite literally, it blasts its foes with a noxious, smelly gas. It's enough to deter this spider, at least.
Oh, finally, stink bug. So we've got a little stink bug here. These eat either plant material or other bugs, and they've got big sucking mouth parts that they use to suck out the insides of either their plant or bug friends, just like a milkshake.
As the day goes on, critters are gathered throughout the house, in every crack and corner. Come evening, the crew gets prepped for the night watch. Many arthropods are nocturnal. It's the best time to find predators.
All right, you getting that?
Yep, got it.
All right, great.
To catch them in action, they're setting up some special cameras. And now, all they need to do is wait. This team wants to know what comes out at night. But how much do you really want to know? Life in the great indoors goes 24 hours. Michelle and Matt wait patiently for the night to deepen.
So, did you ever think when we're getting our PhDs that you'd be crawling around homes looking for bugs?
No, definitely not. No, I was drawn to the rainforest, hunting insects in the tropics, but it's kind of nice to be away from, the mosquitoes, the venomous snakes, have a little more of a domestic expedition site.
Tonight, they are on the hunt for a true beast of the indoor jungle, the house centipede.
That is a lot of legs.
Oh man, look at that thing.
Wow.
Look at that.
Sure, it's creepy, but the house centipede is also amazing.
That thing is fast.
There is no centipede faster than the one that lives in your basement. The secret to its high speed is a respiratory system unlike any other centipede. It's like oxygen fuel injection to power all those legs. And with them, it runs at a human equivalent of 67 kilometers an hour. Its front antennae, sensitive to both smell and touch, allow it to see in the dark. The centipede's first pair of legs have evolved into poison fangs. Tonight, it hopes to use them on this beetle. But while the centipede may be king of the beasts indoors, it doesn't mean it lives carefree. This spider has wandered into the house looking for takeout. Stock still, it has all its eyes on the centipede. But it must decide whether an attack is prudent. When attacked, the house centipede has a startling strategy. It drops a few legs that continue to twitch. They attract the spider, who takes one away, and the centipede escapes. New legs will grow back, although they may not be as good. Still, it's better than being dinner.
Check out the stack of stuff.
Oh, yeah.
Oh, house centipede.
Wow, look at that. That's really, really nice.
It looks like an alien.
I know.
Oh.
Oh, we got it. Gently slide something under.
Yeah.
All right, maybe just the cardboard part of it.
I think it's not too thick. He won't slip out.
Okay,
Let's just
let's,
jiggle it underneath.
Okay, let's up.
There we go.
Okay, let's knock it off into there.
course, you can just put the lid right on it.
Oh, it's crawling out.
Where is he?
Up, don't bite me.
They don't hurt much anyway, right?
I don't want to find out.
He is tricky.
There we
Okay,
go.
perfect.
All right, got the lid.
1, 2, 3.
Okay, there we go. It's cleaning itself now.
Very clean. You would never expect a centipede to be such a clean animal, huh?
Well, they need all those organs to be nice and clean so it can sense everything.
I've kept one of these as a pet before.
Did it come when you called it? I think it's just those long legs that people get freaked out about.
I did notice you didn't want to hold it, though, so.
It was reaching out for me.
It's been a night of mayhem in the basement, but this pill bug has survived. Can it hold out long enough to find a safe place to call home? With its crucial need for moisture, the odds indoors are steep. But a bit of damp shelter may just be the key. There is one nocturnal critter the team isn't finding, and that is good news for this family. But you can't talk about the indoor biome without it. The German cockroach is so well adapted to the great indoors that it lives only indoors. And all our attempts to wipe it out only seem to be making it stronger. Poison bait laced with glucose is one approach that worked well for a time. Roaches take the sweet bait and carry it back to the dark places where their friends live. When properly applied, the method can work. But years ago, entomologists at University of North Carolina discovered something strange. Roaches were no longer taking the bait.
This is cafeteria-style preparation.
And now, Kobe Schall has figured out exactly why.
So we have 2 cages of cockroaches. One cage contains wild-type cockroaches or normal cockroaches, and the other cage contains cockroaches collected from an infested apartment. And these cockroaches evolved this amazing new adaptive behavior that allows them to avoid insecticide bait.
The German cockroach now does something that few other living things do: avoid glucose.
What happens in these cages is that the wild-type cockroaches will feed equally on peanut butter and on jelly that contains glucose, whereas these glucose-averse cockroaches will feed on the peanut butter exclusively. They will taste the jelly, which contains glucose, but they immediately reject it without feeding on it. It's sort of like spinach to a kid.
Amazingly, this new adaptation, bucking several 100 million years of evolution, only took about 3 years to develop.
Glucose aversion is a beautiful example of evolution in process, actually very rapid evolution in process.
The secret was in the tongue. Yes, some people study cockroach tongues for a living. Schall and his assistant fed cockroaches drops of sugar water and measured the response. They discovered that a mutation in the cockroach's taste buds makes sweet taste like bitter.
There's actually a huge cost to not wanting to eat glucose. It's a major, very important energy source for all animals. So the cockroach is actually ignoring a whole array of foods in the kitchen in order to survive the bait insecticides.
And when we change our approach, the cockroach stays one step ahead.
Most recently, the manufacturers, of course, have switched their baits from containing glucose. Some manufacturers have incorporated fructose, another sugar, into their bait. We already find populations of cockroaches in the field, in apartments, that are fructose averse.
We may not like them, but you gotta respect them.
The relationship between pest cockroaches and humans is really an arms race, where we try all sorts of ways to control the cockroach, and a cockroach evolves to avoid whatever it is that we're throwing at it. I view the cockroach as job security. There's no way that we'll come up with anything that will eradicate the German cockroach.
Yeah, it's interesting. We haven't seen any sign of cockroaches in this house, huh?
Yeah, very fortunate, especially for the homeowners.
Yeah, lucky household.
Yeah.
The next morning, the survey goes to the upper level. The rooms in your house are almost like different ecosystems. From the basement, Madiane makes her way to the bioregion known more commonly as the bathroom.
The bathroom is one of the areas where we have more water. And so creatures that like this sort of humidity or need more water are going to be here more reliably. Looks like a midge. So I guess this is one of those creatures that likes this really humid environment. Pretty standard temperatures and humidities most of the day, but the bathroom is one area that goes up and down, really wide variation. When there's a shower, it's hot and steamy. When there's not, it can be quite dry during the day when everyone's out.
For this spider, these drops are the perfect oasis. But suddenly, a flash flood and scorching hot. Any creature that lives in the bathroom has to be able to withstand wild extremes of heat and humidity.
Oh, wow. This looks like some sort of nursery web spider. She's actually got an egg sac. Oh, she's beautiful. She's huge. Now, I don't know where she came from. All it takes, really, is a towel from the beach or your bag from a picnic. Here she is in your house. So I'm sure she's loving this humid environment, because often they're by streams or ponds or things like that. Got her. That large white ball is the female's egg sac. I'm not sure what the fate of her spiderlings will be inside. I suspect that they won't do very well. At that early stage, spiderlings actually require quite a bit of food, and a typical house doesn't have enough prey at that size to support them.
Another creature fond of bathrooms is one that has changed little in over 400 million years. Silverfish can survive on nearly anything. This one feeds on dead skin. They've been with us ever since we first started living indoors, back in the Stone Age. Its flat body and long antennae allow it to find and fit into tiny cracks. Useful features way back then, and still useful today.
When you think about the group of arthropods that seem to have evolved in cave-like conditions, and we have microhabitats like that inside of our house, right? In our basement or behind our cabinets or underneath our sink, because those groups of arthropods have characteristics that make them well adapted to caves. They're also well adapted to certain aspects of human houses.
As the specimens come in, Misha and Michelle do some initial work in the lab.
These can be sorted out better. I think those are mostly like
Kitchen.
those pantry pests.
Yeah, great.
But while work goes on upstairs, life and death continue downstairs. A male cellar spider lays out the last strands of its web. If need be, he will wait stock still for days until good vibrations in the web indicate dinner is served. But this intruder sends vibes of a different kind. A lighter-colored female approaches the male. She wants this web for herself. The male waits for the intruder to make the first move. She probes and tests him. She lunges forward, but he repels her. And she retreats. He quickly makes repairs. But it's not over. The female comes back for another assault. And this time, the male retreats. the intruder sets up camp in her new home. In order to begin some of the identification work, Matt goes to the basement for a box of supplies. The same box that shelters the pill bug. In the great indoors, the fickle human fingers of fate loom large. For this pill bug, the move to the dry main floor could be bad news. It's generally a good life in the great indoors. For one, there's always lots of food. But there's one big drawback. It's so dry, you can die. Warm in winter, cool in the summer, but always dry. For arthropods, our climate-controlled homes can be like a desert. No matter where you might sit on the food chain, without water, it's game over. Many creatures of the great indoors display an astonishing ability to survive what can seem to be an endless drought. They are the creatures found in nearly every home.
I'm looking for some really tiny stuff right now, and so sometimes I like to poke my forceps around nearby so that it scares them into moving and giving away where they're hiding. Oh, see, there's one right here.
Meet the book louse. This tiny critter, no bigger than a period, is the master of moisture. It feeds on mildew and the starch in book bindings. But to beat the dryness, it can take moisture straight out of the air, swelling to several times its original size. And it can live off that vapor for about 3 weeks, which in human terms is like you taking a drink of water every 6 or 7 years.
They're able to take advantage of a lot of the habitats that houses present, and I think that's why they thrive so much in human homes.
All book lice are female and reproduce all by themselves. So if a single louse gets into your house, you could soon have a thriving population. Lucky for us, they are harmless. And lucky for us, they don't fly. In fact, many residents of the indoors don't fly. In the insect world in general, that's pretty rare. Perhaps that's because we humans don't like living with things that flap in our face. Some creatures seem to know that and keep a low profile. They can fly, but prefer hiding out in your closet.
We got a moth.
The bright light spooks a clothes moth from its comfy home. Before it ate our sweaters, it fed on animal hair and bird feathers, but now it feeds mainly in our homes.
So this moth is one of those groups that you find in houses that really closely lives with people. It originated in Western Eurasia and has just spread all around the world through people's luggage and when they're moving because the larvae are so well hidden.
It's in fact the larvae that eat your clothes, not the moth.
So this looks like clothes moth larva damage. There must have been a bunch here at one point.
Whether they like what they find in your closet is largely up to you and to fashion.
The larvae really thrive on a lot of natural fibers like wool. And so when people were really living it up with synthetic fibers in the 70s, their populations weren't nearly as big.
But with the move back to more natural fibers, the clothes moths have returned. And the softer the fibers, the better. Just like you, larvae prefer cashmere. But what if you throw out your old wool sweaters? Food quality for the moth changes drastically. The way it adapts is extraordinary. It puts adulthood on hold.
They can have as few as 5 molts that they go through before they pupate to become an adult, to as many as 45. So that's an insane amount of variation, and I don't know, I can't think of any other group that has that many molts.
For humans, that's like delaying adolescence for about 100 years. This kind of flexibility seems to be a hallmark of life in the great indoors. But perhaps no winged creature is more at home in our homes than the housefly.
Flies have got really good senses of smell. They're always attracted to our food and the things that we bring into our house for ourselves. The antennae on the front of their face are what they use for smell, and they go through the house and are sniffing out what they need to land on. And then when they land on it, they can actually taste the quality of it with taste bud-like things in their feet. They may be transmitting bacteria and various other pathogens around the house just on their feet as they're landing back and forth. And they'll put their mouth parts down and start sponging it up and eating that way. It will actually spit out a little bit of fluid from its mouth to help liquefy the nutrients on top of the food, and then it'll suck that all back up like it's slurping up something off the counter. Fly vomit is basically everywhere in your house, I'm sorry to say.
As it zips through the air, its wings beat more than 200 times a second. But the question everyone has is, why are they so difficult to kill? First, the fly has 4,000 separate lenses in each eye, giving it a field of vision spanning nearly 360 degrees. And with that, in its tiny brain, goes the fastest visual processing system on Earth, detecting about 7 times more information per second than we do. So when you raise the swatter in any direction, this fly sees you coming. Tiny sensors on its body detect the onrush of air. And even when you do hit it, it still gets away.
So when we try and sneak up on a fly, whether with a fly swatter or a vial to catch it in my case, you have to go slow and you have to usually come down over the top and around the back where they've got slightly blind spots.
This ability to leap to safety works remarkably well, which is why it's found in other indoor house guests too. But not all of them leap and fly off. Some just leap.
Springtails are really early insect cousins, so they're not even really officially considered insects. They're subterranean, so they live in the dirt. They have an incredible jumping capacity, which is shocking when you see how tiny they are.
In a tenth of a second, it leaps nearly 100 times its own height in a single bound. It's the stuff of superheroes and science fiction. Now that most of the collecting throughout the house is done, the heavy work of identifying begins.
So we've got Sylvanity, another family of beetles.
I'm gonna put him in with the Curculeonid.
Roughly labeled in their vials, every specimen needs to be sorted and classified.
So yeah, if you could position this one right here, this specimen.
Just a second.
I really want to see that one. Looks very cool.
Part of the job is to separate the insects from the dust, hair, and spider web they came with. Michelle puts one of the beetles under the scope.
It's a minute brown scavenger beetle. These mostly feed on molds in homes. They're even sometimes attracted to new houses. The smells that the drywall and things like that produce actually attract the beetles.
So they have had some recent work done here, so maybe, in fact, that would explain the presence here.
Yeah, that's true. So one specimen isn't bad, but if you have hundreds, that could signify that there's a mold issue or something like that.
Some of the specimens are still alive.
This is the little oatmeal apartment that Misha found in the kitchen. It's got a weevil and a bunch of those grain beetles and even some larvae all living together here in these chunks of oatmeal.
Oh, that one's a nice one. Look at that one. That's far along.
So that's the baby of the grain beetle, the merchant grain beetle.
Yeah.
The team keeps a record of their findings for their research and to present to the family when they return.
Here's one of these weevils. We got quite a few of them.
Okay, so we got Order Coleoptera.
The analysis can take days, but it's a great way to see what they've sucked up.
Whoa.
Yeah, that's definitely the cross orb weaver.
Okay.
It's introduced from Europe and pretty much everywhere here now.
Just a few feet away, the adventures of the pill bug continue. It's not a bad refuge under this plant. It's humid and safe so far. It might even be a good place to raise a family. Unless, of course, the human family that lives here calls an exterminator, after Michelle tells them what they've uncovered.
Well, hello. Hi. Welcome back. Come on in.
Thank you.
The indoor expedition is over. It's time for this family to find out who they're living with.
Welcome to our research lab.
What do you think?
Oh my God.
We found about 112 morphospecies, so 112 different types of things in your house. But don't worry, because you know what? That's pretty typical. It's not.
112.
It's not unusual.
It's not shocking.
I haven't seen 112 bugs.
In my life.
Yeah.
Of special interest to the family are the critters they had been seeing in the pantry.
Is this the flower mite that you were talking about?
Yes.
These are actually two types of beetles that infest stored products. These were in some oatmeal. Inside the pieces of oats, we found some little larvae, and they look like little worms almost.
Thank you for letting us know.
These weevils or snout beetles, are given that name. Here's this long snout that they have, and they have really tiny little mandibles or teeth on the end. And these actually require whole grains, like a kernel of corn. They'll chew into it whole, and then they'll lay an egg in there, or a couple eggs, and the larva will live its entire life inside that piece of corn, and then become an adult weevil, and then you get infestations.
Like, where did they originate from? Our house or from the store? Like from packaging?
It can be from the store. If they've left things on the shelf for too long, they can get in there. But they're perfectly harmless. They're not poisonous. They're not dangerous in any way.
It's because really they're eating oats, which is what you're eating. So even if by accident there was an egg in there or something that you ate, it wouldn't hurt you at all. I know that sounds horrible. I tell my kids that all the time. They've been co-evolving with humans for a very long time.
Yeah. Like, how many years would you say?
With you or humans?
No, humans, not me.
With humans, probably at least 10,000 years when we made this transition from hunter-gatherer societies to agricultural societies and started storing our food. That becomes really appealing for different types of insects.
Are you going to still eat oatmeal?
The next item of show and tell has a troubling name.
So this is called the masked bedbug hunter.
It doesn't only eat bed bugs. That's just its name.
The person who probably first discovered this probably found it eating bed bugs, and so they named it that. But it's actually the skin. So you can see here there's a split in the center.
Yeah.
And the young bug would have popped out of there and hardened. And then what they do is they cover their body in dust and dirt. So they camouflage against their prey, and they'll eat whatever they can come across that they can take down.
Yeah.
These things have a beak that they basically jab into the insect and put venom into it and then suck it dry.
How do they like put the venom into it?
Basically inject it in like a needle.
Imagine you had a really sharp straw and you stuck it into something.
Like a juice box?
Like a juice box, yeah.
That's how you get the juice out.
Yeah.
The wide diversity of life Michelle's crew has found reflects the range of relationships we have with these critters. From arthropods that are strongly adapted to live in our houses, to others that seek indoor benefits from time to time.
Well, these have a venom, just like...
To many others who simply get trapped indoors. Some of them we see rarely, but others are all too familiar, like the pesky fruit fly. Michelle shows the family just what goes on inside a rotting peach.
Oh, those are them?
Yeah, look at that.
What's it feeding on there?
Well, you often find them on rotting fruit, right? So on your bananas or your peaches, that's a maggot. That's a baby fly. Look at it.
What's it coming out of?
He's inside a peach, and he's got two little hooks. Do you see those dark hooks?
Yeah.
And so he's using that to kind of scrape. And so he actually eats fungus and bacteria and really tiny, tiny life on the fruit. And so they're really attracted to the smell of that fermenting fruit. Look at that. That's all the baby maggots at different stages. Right.
That's crazy.
And so you'll notice if you sit outside with a glass of wine or something, these flies can be really attracted to that smell of fermentation.
And what is that? It looks liquidy coming out of the mouth.
So flies actually all feed on some type of liquid. You know, they don't have chewing or biting mouth parts, so they sop it up with that long, spongy mouth part.
I don't think I'm gonna eat food anymore.
They may be a nuisance, but these lowly flies have in fact helped us usher in the modern age of genetics.
And these flies are actually really incredible, not just because they feed on all your rotting fruit, but because they've been incredible model organisms in science. So much of what we know about DNA comes from these little tiny flies.
Really?
Yeah.
That's incredible.
While Michelle goes over the details with the family, life underfoot continues. This pillbug's refuge is working out. For now. But it can't last. Eventually, she'll be forced out or found out. In the great indoors, so much depends on what kind of creature finds her first.
This little guy wouldn't have survived for very long inside, so I decided to set him free.
And so it goes. Life moves out, but more life moves in again. And as we humans spread all over the earth, expect more and more life in the great indoors.